Hello, welcome to the Open Source Hardware Design Expo video. In this video, you're going to hear from 3 of our teams that show a wide variety of what we do here in the Open Source Hardware Enterprise, or OSHE as we like to call ourselves. The 3 teams you'll be hearing from in this video are ATX Power Supply, HMI for Robots, and Hibernacula Manipulation. These 3 projects cover a wide span of what we do here in the Open Source Hardware Enterprise. It'll give you a great insight into what we do here and the different types of work that our students are allowed to do. We have over 10 different projects that we're working on all at the same time. Now, we have teams for each one of these projects, but we have a wide variety of different kind of work that we do. So come to our table and check us out if you want to learn more. Even though we have a wide variety of projects that we do here in OSHE, all of them have at least 3 things in common. The first thing is that each of our projects attempts to be easily replicated. The second thing is that each of our projects tries to be as affordable as possible. The third thing is that each of our projects attempts to be accessible. And to make sure our projects meet those 3 criteria, we're not afraid to buy things online or design something ourselves. In OSHE, we do whatever we can to make our projects meet those 3 criteria. Before I hand it off to our 3 teams that will be presenting at Design Expo, I just wanted to say thank you to our sponsors. Without them, we couldn't do anything we do here in OSHE. And finally, I hope you enjoy the rest of this video, and I hope you learn a lot about the Open Source Hardware Enterprise. Enjoy.
As part of the consumer products branch, the ATX Power Supply project aims to learn how ATX Power Supplies work and how the enterprise can replicate them.
Our alpha prototype serves to expand the power topologies to a larger footprint for design verification. The prototype uses test points to ensure easy testing during the design verification stages.
The main topologies of our design are using an active power factor correction for better efficiencies, an LLC resonant frequency converter to step down the PFC voltage to about 12 volts, and then to also isolate the secondary side from that high voltage, and then have buck converters step that down to further DC to DC conversions.
After verifying our topologies, next semester we're aiming to combine the topologies into the ATX standard form factor. We've been working very closely with our sponsor at Plexus, an analog engineer and an MTU alumni who's helped us with the architecture design all the way through PCB layout.
We are Industrial HMI for ABB Systems in the Open Source Hardware Enterprise. Our project uses a Raspberry Pi and a 7-inch touchscreen display to create an HMI screen that we can use to interface with an ABB robot.
Our HMI aims to complete simple tasks such as moving the robot to different positions and monitoring I/O. We are currently sponsored by Flex Automation, who have been meeting with us weekly to give us feedback and support.
Our project uses a Python script to create an HMI screen, and it currently has several buttons for different robot positions and a button to open and monitor I/O to the robot. The screen is completely customizable due to it being written in Python, and there are different functions that we can implement in the future just by changing the code.
We are using Robot Studio to simulate a real-world robot, using socketing to send messages between the virtual robot and a VS Code program within the Pi. For positions, the Pi will send a number to the Robot Studio program, which will interpret the number as a set of coordinates for the robot to move to.
In the given time, we weren't able to work with the physical robot due to some hardware complications that we ran into, but we were able to create a communication between a closed source robot and our open source program.
During the duration of this project, we learned about socketing, communication between several devices over Ethernet, and the strict limitations of closed source software. Despite the roadblocks, we have still created a project that our sponsors can utilize easily within the manufacturing world.
Hello, we are the Hibernacula Manipulation team, and our objective is to assist the DNR and the College of Forestry in saving the UP bats. We are the representatives for OSHE's Research and Scientific Tools branch of the enterprise. Our objective is to cool down the mines and caves that the bats hibernate in an effort to reduce white nose fungus.
Our systems that we're developing will be used by the DNR to create mini Hibernacula to test whether or not this idea is valid. We have a control system that will control fans, and we have a temperature sensing system that will be set up in the caves to collect data to feed the control system.
Our systems will also feed data back to the DNR so they have an accurate measurement of how well their system is working, so they can correlate their results to the effects that they're seeing in the mines. Another aspect of our project is we have to set up solar panels to power the system because it's in a remote location in the Porcupine Mountains, which is inaccessible to power lines. A major goal of the OSHE enterprise is that our projects can be replicated by other people. This is especially true of our project because if the solution is shown to be viable, it will be most likely used across the nations by DNRs to save the bats.
DNRs are usually composed of non-technical professionals, so we focused on using off-the-shelf parts and solar power to keep it easy to access and easy to use.
If you want to hear about how we're helping our flappy and furry friends flourish, or any of our other projects, please come visit us at Design Expo.